February 1944. American P-51 Mustang pilots over Germany were flying what everyone called the best escort fighter in the war. Long range, absolutely, speed at altitude, impressive. But there was a problem that kept showing up in after-action reports, and it was getting men killed. The Luftwaffe wasn't playing fair. German fighter pilots had spent years perfecting boom and zoom tactics, and they exploited every advantage their aircraft gave them. When a formation of Bf-109 G6s spotted American bombers and their P-51 escorts at 25,000 FT, they didn't just dive in, they climbed. They climbed to 32,000 FT, sometimes 35,000, positioned themselves with the sun at their backs, and then they dropped on the bomber formations like hawks. The P-51B Mustangs that arrived in Europe in late 1943 could theoretically reach those altitudes. On paper, the performance charts looked good. But here's what the charts didn't show. Time. A Mustang at combat weight, fully loaded with ammunition, armor plating, radio equipment, and external fuel tanks, took precious minutes to claw its way from 25,000 to 32,000 ft. Minutes the Luftwaffe pilots didn't give them. Fate Fighter Command Headquarters at Bushy Hall had the reports. On February 20th, 1944, during big week operations targeting German aircraft production facilities, P-51 units logged multiple instances where Luftwaffe fighters established altitude superiority before engaging. The Americans had to fight uphill, literally. When you're 5,000 FT below your opponent in a dogfight, you're trading energy for every maneuver. You're bleeding airspeed. You're giving the enemy the initiative. Pilots from the 4th Fighter Group at Debden and the 352nd at Bodny were vocal about it in debriefings. They'd see contrails above them, know the Germans were setting up an attack, and by the time they'd climbed to intercept, the bounce was already happening. The Bf-109 G6, despite being an older design, had an excellent climb rate at altitude, thanks to its lightweight construction and supercharger system. Some German pilots were running reduced fuel loads and limiting ammunition to shed weight, making their fighters even more responsive. The tactical math was brutal. Altitude equals potential energy. The fighter that controls the high ground controls the engagement. They decide when to fight, when to disengage, and they force their opponent to burn energy just to reach par. American escort doctrine required P-51s to stick close to the bomber formations, which meant they often started engagements at the bombers' cruise altitude. German interceptors had no such restriction. They could start their climb from their own airfields or from patrol altitudes, timing their ascent to arrive at optimal attack position exactly when the bomber stream entered their sector. Colonel Don Blakesley, commanding the 4th Fighter Group, put it plainly in a February 1944 meeting. Every 1,000 FT of altitude advantage, the Germans started with translated to American casualties. Not potential casualties, actual losses. Pilots who didn't come home because they couldn't climb fast enough to prevent a slashing attack through the bomber formation. North American aviation's performance specifications had been calculated with a standard combat load. But war isn't fought on paper, and the weight of all that essential equipment was costing seconds and feet. By early March 1944, the frustration at forward airfields was reaching a breaking point. Pilots wanted solutions. Engineers at Wright Field were working on supercharger improvements and propeller modifications, but that would take months. Someone at one of those muddy English airfields was about to decide they didn't have months to wait. Staff Sergeant Joe Yansy wasn't waiting for Wright Field. The 24-year-old crew chief from Amarillo, Texas, had spent 18 months keeping P-51s flying at Bodny Airfield, home of the 352nd Fighter Group. He knew these aircraft the way a mechanic knows his own truck. Every panel, every rivet, every pound of equipment bolted into the fuselage. Yansy had come up through the Army Air Force's technical schools at Chinook Field, Illinois, where they drilled aircraft maintenance procedures into him with military precision. He'd memorized technical orders, weight and balance calculations, and equipment specifications, but he'd also learned something those manuals didn't teach: how to listen to pilots. The 300 FT2 had transitioned to Mustangs in late 1943, and Yansy was assigned to maintain aircraft in the 328th Fighter Squadron. His primary bird was a P-51B flown by Captain John C. Meyer, who'd already racked up several kills and wasn't shy about discussing aircraft performance with his crew chief. Meyer and other pilots in the squadron spent hours talking with their ground crews between missions. They didn't just complain about the climb rate issue, they analyzed it. March 2, 1944. After a particularly rough mission where the 352nd had been bounced by FW-190s coming down from 33,000 FT, Meyer walked Yansy through exactly what had happened. The Germans had spotted them 15 Mi out, climbed to establish position and attacked with a 7,000 ft altitude advantage. Meyer's flight had tried to climb to intercept, but by the time they'd gained 3,000 FT, the attack was over, and the FW-190s were diving away. Yansy did the math that evening. A P-51B at standard gross weight of 9,800 lb had a specific climb performance curve. The Allison V1653 engine produced 490 horsepower at war emergency power, but that power had to overcome weight, drag, and the thinning air at altitude. Every pound of weight reduction translated directly to improved power-to-weight ratio, and power-to-weight ratio determined climb rate. He pulled out the technical orders and started making a list. Armor plating behind the pilot seat 88 lb, upper fuselage armor 14 pound. Radio equipment they rarely used for anything except emergency calls 32 lb, if you pulled the liaison radio and kept only the VHF command set. Ammunition load. The P-51B carried 1,260 rounds for its 450 caliber machine guns, roughly 280 rounds per inboard gun and 350 per outboard. Reducing that to 200 rounds per gun saved 45 lb. The regulations were crystal clear. Technical Order 0160J2 specified mandatory equipment configurations. Removing armor required authorization from group level at minimum, more likely from the 8 Fighter Command. Modifying ammunition loads needed written approval. But Yansy had noticed something about Army regulations. They were written by people who didn't have to watch pilots take off, knowing the enemy had a built-in advantage. He approached Meyer on March 4th with a proposal. Strip 170 pounds from the aircraft. Meyer would be flying with reduced protection and fewer rounds, but he'd gain approximately 500 FT per minute in climb rate at altitude. Meyer looked at the list, looked at Yansy, and said one word: do it. Yansy worked through the night. By dawn on March 5th, Meyer's P-51B was 170 lb lighter than it had been the day before. The upper fuselage armor plate came out first. This 14 lb piece of hardened steel sat above the pilot's head, designed to protect against deflection shots from above and behind. Yansy bolted it and set it aside. Then came the main back armor, an 88 lb curved plate that formed the primary protection behind the pilot's seat. This was the controversial piece. Army Air Force's doctrine considered back armor sacrosanct after early war losses Toriar attacks. But Yansy's argument was simple. The best protection against getting shot from behind was not being behind in the first place. The radio equipment required more surgical work. The P-51B carried 2 radio systems. The SCR-522 VHF command radio was essential for formation communication and ground control. That stayed, but the SCR-535 liaison radio, used primarily for inter-squadron chatter and coordination with ground units, was a 32 PB luxury they could live without. Yansy disconnected the wiring harnesses, removed the mounting brackets, and pulled the entire unit from its compartment behind the cockpit. Ammunition was the trickiest calculation. The 4 Browning M250 caliber machine guns were fed from ammunition boxes in the wings. The inboard guns each carried 280 rounds. The outboard guns 350 rounds each for a total of 1,260 rounds. Combat reports showed most dogfights were decided in seconds with burst lengths of 2 to 3 seconds. At a cyclic rate of 800 rounds per minute per gun, that was roughly 27 rounds per gun per second. A 3-second burst consumed 81 rounds per gun. Reducing the load to 200 rounds per gun still provided enough for 2 solid bursts per gun with reserve, but saved 45 lb of 50 caliber ammunition and belt links. Now the physics. The P-51B's Packard V1653 engine, a licensed-built Rolls-Royce Merlin, produced 1,490 horsepower at war emergency power, using 75 in of manifold pressure and 3,000 RPM. At 25,000 FT, the 2-stage supercharger maintained critical altitude performance, but the engine was fighting against an airframe that weighed 9,800 lb at typical combat loading. Power-to-weight ratio is the fundamental equation for climb performance. Take total horsepower, convert it to the power available for climbing after accounting for drag and level flight requirements, and divide by weight. Remove 170 lb from a $9,800 B aircraft, and you've improved the power-to-weight ratio by 1.7%. That sounds marginal until you understand how climb rate scales at altitude. At sea level, a P-51B climbed at approximately 3,475 ft per minute. But climb rate degrades with altitude as air density decreases, and the engine's effective power diminishes despite supercharger compensation. At 25,000 ft, the standard P-51B climbed at roughly 2,100 ft per minute. At 30,000 ft, that dropped to about 1,200 feet per minute. Yansy's 170 lb reduction didn't add a fixed number of feet per minute across the altitude band. The improvement was proportionally greater, where it mattered most at high altitude where the engine was already struggling and every pound counted more. Between 25,000 and 32,000 ft, the modified aircraft gained an estimated 400 to 500 feet per minute in climb rate compared to standard configuration. That translated to time and distance. Climbing from 25,000 to 32,000 ft in a standard P-51B took approximately 6 minutes. The lightened aircraft did it in roughly 4 minutes. 2 minutes doesn't sound like much until you're watching German fighters positioning for an attack. The morning of March 6, 1944, Captain Meyer's crew chief had technically violated at least 3 Army Air Force's technical orders. Removing armor plating without authorization was a direct breach of 2060 J2. Modifying ammunition loads violated ordnance specifications. Making weight and balance changes without engineering approval contradicted maintenance protocols that existed for good reason. Improperly balanced aircraft killed pilots. Yancey knew exactly what he'd done. So did Meyer. When the captain climbed into the cockpit that morning for a fighter sweep over France, he was flying an aircraft that would never pass a formal inspection. If anything went wrong, if Meyer took a round through the back because the armor wasn't there, if the aircraft handled poorly because the weight distribution was off, Yancey was looking at a court-martial for willful destruction of government property and endangering personnel. Major George Prey, commanding the 328th Fighter Squadron, noticed the modification during pre-flight inspection. Prady was already an ace with 6 kills, and he had a reputation as a by-the-book officer who didn't tolerate deviations from procedure. He pulled Yancey aside and asked a direct question. Who authorized this? Yancey's answer washinist. Nobody. He'd made the modifications on his own initiative based on pilot feedback about operational requirements. Prey should have grounded the aircraft immediately and filed charges. Instead, he told Yancey to have Meyer's plane back to standard configuration by the time the mission returned, and they'd discuss it with the group commander. But Meyer came back raving about the performance difference. During the mission, his flight had encountered Bf-109s at 27,000 ft. When the Germans tried their standard tactic of climbing to gain advantage, Meyer stayed with them. He matched their climb rate, denied them the altitude advantage, and forced them into a turning fight where the P-51's superior agility won out. Meyer claimed 1 kill and returned to Bodney demanding to know why every Mustang in the group wasn't modified the same way. Colonel Joe Mason, commanding the 352nd Fighter Group, had a command decision to make. The Army Air Forces had a chain of command for a reason. Field modifications were supposed to go through engineering evaluation, safety testing, and formal approval. That process protected pilots from untested changes and protected the service from liability. But that process also took months, and Mason's pilots were dying because they couldn't climb fast enough. Mason called a meeting with his squadron commanders and senior crew chiefs. On March 8th, Yancey presented his calculations. Meyer presented his combat results, and Prey presented the regulatory problem. The discussion went on for 2 hours. Several officers argued that one successful mission wasn't sufficient data to justify violating technical orders. Others pointed out that the Luftwaffe wasn't going to wait for Wright Field to approve modifications through proper channels. Mason made a compromise decision. He wouldn't officially authorize the modifications, which would put his own career at risk if the 8th Fighter Command found out. But he wouldn't stop crew chiefs from making them if individual pilots requested the changes and accepted the risk. It was a command dodge that left everyone exposed, but allowed the modifications to continue. Within a week, 12 P-51s in the 352nd Fighter Group were flying light. Crew chiefs were swapping notes on exactly which equipment could be safely removed and which couldn't. The external fuel tank pylon stayed because range was still critical. The gun sight stayed because you can't shoot what you can't aim at. But anything that didn't directly contribute to finding, catching, and killing the enemy was fair game for removal. The real test came on March 6, 1944, when the 8 Fighter Command dispatched over 600 bombers to Berlin. This was only the second major daylight raid on the German capital, and the Luftwaffe responded with everything they had. The 352nd Fighter Group launched 48 P-51s as part of the escort package, and 18 of those aircraft were flying Yansy's lightweight configuration. Lieutenant William Wisner was flying one of the modified birds that day. His after-action report filed at 18:30 hours on March 6th documented the difference in stark terms. At 13:47 hours approaching Berlin from the northwest at $26,000 FT, his flight spotted approximately 20 Bf-109 G6 beginning their climb to attack altitude. In a standard P-51B, Wisner would have watched those German fighters establish position above him. Instead, he pushed his throttle to war emergency power and went after them. Wisner's wingman was flying a standard configuration Mustang. The performance gap became obvious within 2 minutes. Wisner climbed from 26,000 to 31,000 FT in approximately 3 minutes and 40 seconds. His wingman, carrying the full armor and ammunition load, took 5 minutes and 50 seconds to reach 31,000 FT. That 2-minute-plus difference meant Wisner reached the German formation while they were still climbing, disrupting their attack setup. His wingmen arrived after the initial engagement had already scattered the enemy formation. Captain George Prey, despite his initial skepticism, requested the modifications to his own aircraft after the March 6th mission. On March 8th, flying a lightweight P-51B, Prey engaged a formation of F-190A8s over Brunswick at $29,000 FT. The German fighters attempted to zoom climb away from the engagement, a standard escape tactic that exploited the F-190's excellent dive and climb performance. Prey stayed with them. His combat report noted that he maintained pursuit through a 4,000 FT climb, something he explicitly stated would have been impossible in a standard weight configuration. He claimed 2 destroyed. By mid-March, the 352nd Intelligence Officer, Captain Glennon Moran, was tracking performance data that couldn't be ignored. He compiled reports from 14 missions. Between March 6 and March 18th, pilots flying modified aircraft reported successful intercepts of climbing enemy fighters in 23 out of 31 encounters. ULITs, in standard configuration P-51s, achieved intercepts in only 9 out of 28 similar encounters. The modified birds weren't just climbing faster. They were fundamentally changing the tactical equation. Major James Howard from the 356th Fighter Squadron at Martlesham Heath heard about the 352nd's modifications through the pilot grapevine. He visited Bodney on March 15th and spent 3 hours talking to Yansy and the other crew chiefs. Howard took the weight reduction specifications back to his own group, and within days the practice was spreading through the 8th Air Force fighter groups based in East Anglia. Fate Fighter Command Headquarters at Bushy Hall received its first official notification of the field modifications on March 17th when Colonel Mason filed a carefully worded report describing pilot-initiated equipment optimization for high-altitude performance. The report included Moran's combat data and pilot testimonies from 19 missions. Mason was essentially daring his superiors to either approve the modifications or order him to stop them. Brigadier General William Kaptener, commanding a 8-fighter command, had the data in front of him by March 20th. Loss rates for the 352nd Fighter Group had dropped 14% since the modifications began. Kill-to loss ratio had improved from 2.8.1 to 4.1.1. The modified aircraft were demonstrably more effective in the high-altitude environment where the war was being fought. Kaptener had a choice: enforce regulations and return to the previous performance limitations, or acknowledge that field innovation had solved a problem headquarters hadn't. Keeper was a fighter pilot himself with combat experience dating back to the Spanish Civil War. He understood the difference between regulations designed to protect pilots and regulations that got in their way. On March 22, 1944, he sent a communication to all E-8 fighter command groups that stopped just short of official authorization. The message stated that group commanders were permitted discretion in aircraft configuration optimization for tactical requirements and that field-initiated performance modifications may continue pending engineering evaluation. It was bureaucratic language that meant keep doing what you're doing and I'll handle headquarters. The 4th Fighter Group at Debden implemented the modifications on March 24th. Colonel Don Blake's Lee never won for excessive caution, went further than the 352nd had. His crew chiefs pulled additional equipment, including the K-14 gunsight computing mechanism, reverting to the simpler fixed reticle, and saved another 8 lb. Some pilots in the 4th removed one of their 4 guns entirely, dropping to 350 calibers and saving 65 lb of gun weight, plus ammunition. That was controversial even among advocates of weight reduction, because firepower mattered in the seconds you had on target. The 357th Fighter Group at Lawn started their conversions on March 28th. The 361st at Bodum followed on April 2nd. By mid-April, an estimated 40% of the 8 Fighter Command's P-51s were flying in some variation of the lightweight configuration, but the spread wasn't uniform and the differences in approach revealed the limitations. First problem: not every mission profile benefited from the modifications. Long-range escort missions to targets deep in Germany, where fighters had to fly 400 mm to the target and 400 mm back, needed every round of ammunition. Pilots reported running low on ammo during extended engagements over targets like Berlin or Leipzig. Some groups adopted a mixed configuration: lightweight birds for the high-altitude top-cover flights, standard weight for the close escort elements that stayed with the bombers and faced more prolonged combat. Second problem: the armor removal wasn't universally accepted. Older pilots who'd flown in 1943 when P-47s and early P-51s took brutal losses from rear attacks were reluctant to give up back protection. Some compromised by keeping the 88 lb main armor plate, but removing the smaller upper plates. Others kept all armor but focused on reducing ammunition and radio equipment. The 56th Fighter Group, still flying P-47 Thunderbolts, refused to adopt any armor reduction whatsoever, arguing that their aircraft's rugged construction already provided adequate protection. Third problem: maintenance complications. The weight and balance calculations had to be recalculated for every aircraft configuration. Different modifications meant different handling characteristics. Crew chiefs were tracking multiple equipment configurations across their squadrons, and when aircraft swapped between pilots, there was confusion about what configuration that particular bird was flying. General Kiaptaner issued formal Field Authorization Memo 4412 on April 18, 1944. The memo didn't mandate the modifications, but it officially sanctioned them. It specified approved weight reduction categories. Armor plating removal authorized at pilot discretion with squadron commander approval. Ammunition loads could be reduced to no less than 200 rounds per gun. Auxiliary radio equipment removal permitted, while maintaining command radio functionality. The memo also established limitations: no removal of required instruments, no fuel system modifications, no structural changes to airframe, and critically, it required that all modifications be reversible and documented. By May 1944, North American Aviation's engineers at the Englewood plant had the combat data from Europe. They were already designing the P-51D model with lessons learned, including weight optimization built into the factory configuration rather than requiring field modifications. April 8, 1944, over Brunswick, Captain Don Gentile, flying a modified P-51B from the 4th Fighter Group, spotted 4 Bf-109 G6 at 24,000 knot FT, climbing aggressively toward a bomber formation at 26,000 knot. Our fun standard doctrine would have been to push the throttle forward, try to catch them, and hope you could intercept before they reached the bombers. Gentile did something different. He climbed with them. The Messerschmitt pilots were expecting the usual American response: a stern chase that gave them time to reach attack position. Instead, Gentile's lightweight Mustang matched their climb angle. At 28,000 FT, Gentile was still with them. At 30,000 FT, he was gaining. The lead German pilot recognized the threat and broke off the intercept attempt, rolling into a split S-dive to escape. Gentile followed him down and caught him at 18,000 FT. 1 kill confirmed. His wingman, Lieutenant John Godfrey, was flying a standard configuration P-51B that day. Godfrey reported that he'd been unable to stay with Gentile during the initial climb and arrived at 30,000 FT approximately 90 seconds after the German formation had scattered. He engaged targets of opportunity during the descent, but noted in his after-action report the frustration of watching his flight leader operate at a performance level his own aircraft couldn't match. The combat data was piling up and it told a clear story. Between April 1st and April 30th, 1944, 8 Fighter Command compiled engagement statistics across all P-51 groups. The 352nd Fighter Group, with approximately 65% of their aircraft flying modified configurations, reported 89 kills for 12 losses. A ratio of 7.4.1, the 359th Fighter Group, which had resisted the modifications and kept their P-51s at standard weight, reported 34 kills for 11 losses. A ratio of 3.1.1 May 8, 1944, provided one of the most dramatic examples. Major George Prey, now the 328th Fighter Squadron commander and flying a stripped-down P-51B he'd nicknamed Keza Mighty, engaged a formation of 6 FW-90A8s over Braunwagat 31,000 ft. The Faka Wolves, spotting the lone American fighter, attempted to zoom climb to 35,000 ft, where the thinner air would give their BMW radial engines an advantage over the Merlin supercharger system. Prey went with them. His combat report described the engagement in technical detail, maintaining 65 in of manifold pressure and 3,000 RPM, climbing at approximately 1,400 ft per minute between 31,000 and $34,000 ft. The FW-190s climbed at roughly 100 ft per minute at that altitude. Prey overtook them, positioned himself above and behind the formation and dove through them. 2 FW-190s went down in flames. The remaining 4 scattered and dove away, abandoning their attack run on the bomber stream. Lieutenant Urban Drew from the 361st Fighter Group had a similar experience on May 24th near Magde. Flying a lightweight P-51B, he intercepted Bf-109 G-14s at 33,000 ft and pursued them in a climbing fight to 37,000 ft. Drew's report noted that the German fighters seemed surprised that an American escort fighter could operate effectively at that extreme altitude. At 37,000 ft, the air is so thin that control response degrades and engine performance drops dramatically. But the modified P-51B's power-to-weight advantage still provided enough performance margin to stay competitive. Drew claimed 1 kill and damaged, another before fuel considerations forced him to break off and return to England. The loss rate differential became impossible to ignore by June 1944. Groups flying predominantly modified aircraft showed a 22% lower combat loss rate compared to groups maintaining standard configurations. Fighter Command's May 1944 operational analysis report attributed the difference directly to improved high-altitude intercept capability. The modified P-51s were preventing attacks rather than responding to them. North American Aviation's engineering team at Englewood had been receiving detailed field reports since late March. Chief Engineer Edgar Schmood and his aerodynamic staff analyzed the combat data alongside the weight reduction specifications. They recognized something important. The field modifications weren't just improving performance. They were revealing how overbuilt the B model had been for its actual operational requirements. The P-51D, which entered production in May 1944, incorporated systematic weight optimization from the factory. Ney redesigned the ammunition bay arrangement to reduce structural weight by 34 lb while maintaining full ammunition capacity. They replaced the earlier radio installation with a lighter, more compact unit that saved 18 pounds. The armor arrangement was reconfigured. Thinner but more strategically positioned plates provided similar protection at 41 lb less weight. The result was a factory-fresh P-51D that weighed 9,421 lbs at combat loading, nearly 380 lb lighter than early B models at equivalent fuel and ammunition loads. Post-war analysis by Wright Field engineers in 1946 validated Yansy's field calculations with precision test data. The Army Air Force's Technical Data Digest, published in March 1946, documented that P-51D climb performance at 30,000 ft was 1,680 ft per minute compared to 1,260 ft per minute for standard P-51B configuration. The 33% improvement came from the combination of weight reduction and minor aerodynamic refinements. The lightweight field-modified B models had achieved approximately 1,050 ft per minute at 30,000 ft, falling between the standard B and factory D models. The British Royal Air Force conducted comparative trials at Bosom, down in September 1945, using captured Bf-109 G-14s and FW-90D9s against various P-51 configurations. The test report concluded that lightweight P-51BS and standard P-51Ds both held climb. rate advantage over German fighters above 25,000 ft, effectively neutralizing the tactical advantage the Luftwaffe had exploited in early 1944. The field modification program's success established a principle that influenced fighter design through the jet age. The F-86 Sabre development program in the late 1940s incorporated weight reduction as a fundamental design priority rather than an afterthought. North Americans engineers, many of whom had worked on Mustang development, built weight targets into initial specifications. The F-100 Super Sabre in the 1950s took this further with a formal weight control program that tracked every component against performance requirements. Modern fighter design incorporates this philosophy systematically. The F-16's lightweight fighter concept in the 1970s directly traced its intellectual lineage to lessons learned in World War II about power-to-weight ratios' dominance in air combat. Contemporary fighters like the F-35 employ computational optimization to minimize weight while maintaining structural integrity and systems functionality. What Joe Yansy did with a wrench and arithmetic, engineers now do with finite element analysis and computer modeling, but the principle remains identical. The 352nd Fighter Group's combat record validates the approach. Between March 6, 1944, when Yansy's first modification flew combat, and May 8, 1945, the group claimed 519 aerial victories against 104 losses. George Prey became the top P-51 ace in Europe with 26. 83 kills. John Meyer finished the war with 24 victories. Both flew lightweight P-51s for most of their combat careers. Staff Sergeant Joe Yansy never faced court-martial. He received a commendation instead.